To start us off in Module 8, we're going to first look at the area of just polygons, so meaning our closed figure shapes. And then we're going to extend from that into surface area and volume. So, here's a couple of formulas that we may know, but we also might not know. I hope that you know how to find the area of a rectangle by doing length times width or base times height. However, you may not know that a parallelogram has the exact same formula, so you may want to jot that down somewhere in your notes. So when we're looking at this, remember that your base and height have to be perpendicular to each other. So we've got our base and our height with a 90-degree angle shown there. Or if we turn this figure, we also have our base of the figure here, but its vertical height is drawn outside the figure. And that is totally okay. It's still showing us how tall that is. In fact, if I spin this picture, you can kind of take a little bit of a closer look at that. So if I spin this here, we do have our base and our vertical height. So even if our height is drawn outside the figure, we can still use that to find the area. So with that, very quickly here, our base and height are the two numbers that are perpendicular to each other. So that is 20 square inches when I multiply base times height. Here, my base is 2, my vertical height is 3.5, so that's 7 square centimeters for area. For this next part here, what is DE to the nearest 10th? So what we're trying to figure out is how tall this shape is. So if I think about that, my area is supposed to equal the base times the height, no matter what. So if I turn this figure around, I can look at it this way and say my base is 13 and my height is 9. So my area should be whatever I get when I do 13 times 9, which comes out to be 117. So I know the area of that yellow region is 117 square inches all the time. So what I can do to find DE is now I can look at this as my base with an unknown height, right? Because if our area never changes, then that base times the height should also equal the other base times the height. So I'm going to take that 117 and divide by 9.4, and it did tell me to round to the nearest tenth, so my height is approximately 12.4 inches. We're going to do a similar process here. I know if this length is 14, this is as well. So 14 times 8 is my area. If I think about that flipped the other way, my base is 10 and my height is unknown. So 14 times 8 equals 112. So dividing by 10, 11.2 is that value of H. Try this last one on your own, then come back to check. So my base is 0.4 times my height of 0.3 should equal this base, 0.5, times this height here, because our area never ever changes. So 0.4 times 0.3 gives me 0.12. My final step is going to be to divide that by 0.5. So 0.12 divided by 0.5 gives me a height of 0.24. Next, we're going to review the area of a triangle formula, which again, hopefully you know that, base times height divided by 2, or 1/2 base times height. However, we're going to step this up a little bit here. When we look at this triangular sail, notice we've got feet and inches here. So we want to be careful. It is going to ask us for square feet at the end. So let's be very, very careful here. My easiest path when I multiply these is going to be to get them all in a consistent unit. So I've got 12 feet and 2 inches. My easiest thing to do would be to multiply that 12 by 12 so that I've got 144 plus 2 inches. So I've got 146 inches for my height. And then 13 times 12 gives me 156. So 156 plus 4 gives me 160 inches for my base. So my area is 1/2 the base times the height. So half of 160 times 146 gives me an area of 11,680 square inches. However, they want my answer in square feet. So now I'm going to create a conversion chart. So 11,680 inches squared. I can write any number over 1. And I'm going to convert that into feet. Now I know that there are 12 inches in a foot. So I'm going to put inches in my denominator so that one of these inches squareds will cancel out. So since I have 2 of them, I'm going to need to do this again so that I now have inches squared in the bottom and inches squared in the top so that they cancel out, and I'm left with my answer in feet squared. So now I multiply across the top, multiply across the bottom, and divide. So 11,680 divided by 144 gives me 81 and 1/9, or 81.1 repeating. Since they want to know how many square feet we need, we would end our answer with feet squared. So we need approximately 81 and 1/9 square feet of material. To find the area of composite figures, we just find the area of the 2 figures and add them together. So we're going to find the area of the square and add it to the area of the triangle. So a 6 by 6 square plus a 1/2 base times height for the triangle. My base here we know to be 6 because of that congruency marking, and my height is 8. So really I have 36 plus half of 6 and 8 gives me 60 square inches for my total area. For a trapezoid, our formula is 1/2 height times base 1 plus base 2. And I typically am going to write this a different way. I'm going to say half of base 1 plus base 2 times height. Now we know because of the commutative property that those mean the exact same thing. But to me, this helps me see what we're actually doing. So what that first part is doing is it's averaging these 2 bases to help me find the area. So it's essentially saying if I've got 2 different size bases, let's find the average of that and multiply it by the height. So looking at Nevada, we've got our 2 parallel bases are here and here. So I'm going to use my formula 1/2 base 1 plus base 2. Doesn't matter which one you call base 1 and 2 because of that commutative property. Times 309. So I've got 1/2 of 205 plus 511 times 309 gives me 110,622 square miles for the approximate area of Nevada. Try the next one on your own and then come back to check. So our 2 bases are 12 and 15, so we're going to find the average of those and then multiply by 7. So half of 12 and 15 times 7 gives me 94.5 square centimeters. So looking at this triangle, I see, or not this triangle, or excuse me, this trapezoid, I see that I've got my 2 bases, but I don't have this vertical height. So I'm going to add that to my picture here. I know that all across the bottom is 7, and I know that just this part is 5, meaning this part here should be 2. And if I look at that, I've got a 30, 60, 90 triangle where I know the shorter leg, and the longer leg is supposed to be the shorter leg times the square root of 3. So I'm using that 30, 60, 90 rule here in another context. Again, guys, that's not going to go away. So make sure that we still know those 45, 45, 90, and 30, 60, 90 rules. So we're going to take half of base 1 plus base 2 times our height. Now it doesn't ask for this here, but I'm going to ask that you leave your answer in simplest radical form. So to do that, we're going to take care of all of these digits here in our calculator. So we're going to end up with 12, and we're going to bring the square root of 3 along for the ride. So we end up with an area of 12 square roots of 3 with the meters squared. Now, like I said, our 45, 45, 90s aren't going away either. So our next question says, imagine that instead this was a 45-degree angle. How would that change our answer? So we've got 7 and 5, just like before. The only thing that they said to change was the 45. So now, with this 45, 45, 90, our legs should be the same size. So I'm going to bring that 2 over. Half of base 1 plus base 2 times our height. So half of 5 and 7 times 2 gives me 12 square meters for my area. This is also a formula that you may not know yet. So for a rhombus or a kite, our formula is 1/2 diagonal 1 times diagonal 2. Now I'm going to be honest with you guys, we have a lot of things throughout this class that you need to memorize, but this is probably not one of them, because if we think about that, a rhombus is simply made up of 4 triangles, and I already know how to find the area of a triangle. So I can find the area of each triangle and simply add them together. And in fact, that's what this formula is doing, is it's taking half of diagonal 1 times diagonal 2, treating one of them as the base of the triangle and one of them as the height. So if you prefer to memorize it, you can, or you can simply find the area of each triangle and add them together. So what I mean by that, if we want to look at these as triangles instead, we've got a 90-degree angle here since that's a kite. So our base of that triangle would be 6 with those 3 and 3 put together. So half our base times our height of 5 plus the area of this triangle also has a base of 6 times our height of 2, and I can add all of that together. So half times 6 times 5 plus half times 6 times 2 gives me an area of 21 square meters. Or you could have plugged into that formula saying half of total diagonal 1 times the total of diagonal 2, and you will end up with the exact same answer. So looking at what we have here, we've got the high occupancy vehicle, or HOV lanes, is marked by a diamond, which is really a rhombus, marked on the pavement. We want to find the area of the HOV lane diamond shown to the right. So with that, since this is a rhombus, remember that if this is 2.5, so is this. So if I want to find the area of that triangle at the top, I'm going to have to figure out that vertical height. So off to the side, I'm going to use Pythagorean theorem to find that missing information. Now I'm going to do this a little bit quickly here just to save a little bit of time. And I'm going to end up with x squared equals 36. So x is 6. So what I've just figured out is that this guy here is 6. So for that top triangle, half the base, so the 2.5's added together, times the height, but I still need to add on the area of this triangle down here. But in a rhombus, remember, these are equal, so I don't have to do Pythagorean theorem again. I can simply do half the base times the height again. So half of 5 times 6 plus half of 5 times 6 again gives me 30 square feet. For this rhombus here, again, we've got to remember those properties of a rhombus. So that tells me I've got a 90-degree angle here. If this is 8, so is this. And then if I look, what I need to find are these missing informations here and here. So because of that, I can do 8 squared plus x squared equals 10 squared. Or I can recognize that this is a 3, 4, 5 triangle where each of those are multiplied by 2. So I've got 6 and 6. So if I want to find the area of this top triangle, half the base times the height plus this triangle on the bottom here is going to have the same base and height. So half of 12 times 8. So really, what I end up with is 96 square inches. From here, you've got two other ones, so I would recommend that you try these on your own and then come back to check. Notice that it does say to leave your answer in simplest radical form. So for this rhombus, we've got 3 here and 3 here. Since this is a 45, 45, 90, we've got 3 here and 3 here. So really, this particular rhombus is actually just a square. So with that, if I want to find the area of this top triangle, I've got half of 6 times 3 plus, on the bottom, half of 6 times 3. So what I end up with is 18 square centimeters. Over here, we've got 4 and 4. Since this is a 30, 60, 90, this particular piece will be 4 square roots of 3 as the longer leg. So if I'm looking at the area of the triangle on the top, 1/2 the entire base times the height, plus on the bottom, same thing here, 1/2 the base times the height. And if I'm leaving this in simplest radical form, what I end up with is I've got half of 8 is 4. 4 times 4 is 16. So I've got 16 square roots of 3 plus another 16 square roots of 3. Those can be combined to 32 square roots of 3 meters squared. So now we're going to talk about how to find the area of what we call a regular polygon. So remember that regular polygons have all equal sides and all equal angles. So with that, we're going to introduce a new vocabulary word here that looks a little bit funky, but how we pronounce that is apothum, which sounds kind of like we're saying possum incorrectly, but that is how we pronounce it. The apothum is the distance from the center of the figure straight down. If you notice, what we've created here is we've created triangles within this figure. So if we look more specifically, we've created 6 congruent triangles inside this figure. So if I'm just kind of thinking through this generically, I already know that the area of a triangle is 1/2 base times height. And if I look at that figure, I know that I've got 6 of those. So even if I forget this formula that we're about to learn, we can use the fact that we've got one triangle 6 times to find our answer. So with that, we've got this 5-sided figure with an apothum drawn. So we need to find the measures of angles 1, 2, and 3. So angle 1 is one of those central angles, and we know all around the center we have 360 degrees. So if I take 360 and divide it by 5 equal angles, I've got 72 degrees for each of those central angles. But then the apothum is splitting that angle in half. So for angle 2, I've got 36 degrees. And then for angle 3, it's the third angle inside of that right triangle. So I've got 180 minus 90 minus 36, which leaves me with 54 degrees. Now this doesn't have the entire figure drawn, but they do tell us this is an octagon. So see if you can come up with the measure of angle 1, 2, and 3 on your own, and then come back to check. So for angle 1, we're going to take 360 and divide it by 8 equal regions. That's a 45-degree angle for each of those central angles. Then remember that the apothum is going to cut that in half. So we're going to have 22.5 degrees. Last but not least, we have a right triangle here where we've got 180 minus 90 minus 22.5, which leaves me with 67.5 degrees for angle 3. Now, why does that matter, right? So we're going to need that information here in just a little bit. But before we get there, you want to get this formula in your notes. The area of a regular polygon is 1/2 the apothum times the perimeter. Now remember I said really what we're doing is we're finding the area of multiple triangles. So what this formula is doing, instead of doing 1/2 base times height, is it's implying that the apothem is the height of each triangle. And if I take all of the collective bases of these triangles, that would be our perimeter. So really what this formula is doing is it's simply taking the area of all the triangles in one step. If you forget the formula though, remember that you can create this triangle, find the area of this one triangle, and then multiply it by how many equal triangles there would be inside of this figure. So in this case, there would be 10 of them since it's a decagon, and I would still end up with the same answer. But because we have our formula here, let's use that. So 1/2 our apothem from the center down is 12.3, and our perimeter would be 8, 8, 8, 8, 8, 8, 8, all the way around. We've got 10 of those 8s, which means we've got a perimeter of 80. So now I'm going to do 1/2 of 12.3 times 80, and I'm going to end up with an area of 492 square inches. So now we don't have a picture, but we know that we have a pentagon, so we know we've got 5 sides. So if you're a visual learner, you may want to try to draw this. If you're not, you may be able to do this without that. And notice that this is a regular pentagon, so all of those sides should be equal. You guys can tell I'm not great at drawing those, but bear with me here. We've got an 8 centimeter apothem, and one of the sides is 11.6. So using my formula, 1/2 the apothem times the perimeter tells me 1/2 of 8 times 11.65 times, right? That would be my perimeter of 58. So 1/2 of 8 times 58 gives me an area of 232 square centimeters. Again, guys, for perimeter, we're just adding up these sides here. Since there were 5 of them, I multiplied that number by 5 to quickly get my perimeter. So next we have a regular hexagon. So we've got a 6-sided figure this time. Again, if you want to draw a picture here, you can. That would probably be the best advice I can give you, is when you get to these questions, just give yourself some sort of visual to look at. The length of a side is 3 millimeters, and we need to find the area. So our area formula, again, 1/2 apothem times perimeter. So if I'm looking at this, I don't know what the apothem currently is, but I've got 3 millimeters on each side, so 3 times 6 gives me a perimeter of 18 millimeters. So what I need to find is how long is this guy right here. So to do that, I'm going to split this into 6 congruent triangles. So I'm going to take 360 and divide it by 6 to get this central angle here. And when I do that, notice the apothem is going to cut that 60 into 2 equal pieces. It's also going to cut the base into 1.5 and 1.5. Now at this point, my picture is really little for that triangle, so I'm going to redraw this here a little bit. So I've got 30 degrees and 1.5, and I need to know how long the apothem is. So again, this is a 30, 60, 90 triangle. Those rules are not going away. We know the shorter leg is 1.5 because that's across from 30. Remember, your longer leg is always your shorter leg times the square root of 3. So my apothem is 1.5 square roots of 3. I'll bring that right back over here and plug in to my formula. So 1/2 of 1.5 times 18, I'm just going to carry that square root of 3 along with me. It tells me I've got 13.5 square root of 3 millimeters squared. Now it doesn't specify if it wants us to leave it in simplest radical form or not, so you could go ahead and round that answer here to about 23.4 millimeters squared, and either of those would be acceptable. So I would recommend that you try this one on your own. It's going to be another hexagon. This time they tell us you can round to the nearest square foot. Go ahead and try to find the area and come back to check. So I already know, because I've already done this, that I've got 30, 90, and 60 here. But I'm going to label the info I know. I know that we've got 16 for the side, so that's going to split into 8 and 8. So my shorter leg is 8. That's going to tell me my longer leg is 8 square roots of 3. So my formula, 1/2 the apothem times the perimeter. My apothem I just found to be 8 square roots of 3. And my perimeter, I've got 16 all around that 6 times. So 96. So 1/2 of 8 times 96 is 384 with the square root of 3 still attached. Our units here are feet squared, but it does say to round this particular one, so we're going to go ahead and type that in our calculator, and to the nearest square foot, we have 665 square feet. Now there are going to be several of these here for us to try, and we're going to kind of come back and look at our 30, 60, 90, our 45, 45, 90, all of those sorts of things. However, my advice to you is not to forget what you already know about these figures. Meaning, if the first picture here is a regular polygon, meaning all the sides are equal, all the angles are equal, then I know that picture 1 is just a square. And if that apothem is 5, then that distance is 5 also, which means we've got 10 and 10 for our 2 side lengths, because this is a square. So my area is just 100 square inches. For the one at the bottom, so with this next question, we've got this 2 here, and notice that that 2 is going, oops, sorry guys, that just reopened on us. Let me try to close that back. We've got the 2 from the center to the corner, so I know that this is also 2 and this is also 2. So with that, around the center there, I've got 360 divided 3 ways, so I've got 120 degrees. But when I drop the apothem, that's going to split into 30, 60, and 90. Now I know that's a little bit small, so I'm going to redraw that here. I know my hypotenuse is 2, which means my shorter leg should be 1, because the hypotenuse is supposed to be double the shorter leg. So with that, I now know my apothem is 1. But I need to be able to find the perimeter of this figure. So I've got a 1 here for that shorter leg, and I've got a 1 square root of 3 for the longer leg. But notice that that means we would have another one of those over here. So our total of that side is 2 square roots of 3. So when I go back to my formula, 1/2 apothem times perimeter, my apothem was just 1. But I've got 2 square roots of 3 for this side, 2 square roots of 3 for this side, and 2 square roots of 3 for this side. So I really have 6 square roots of 3. So leaving this in simplest radical form, I end up with 3 square roots of 3 meters squared. However, it does tell me that I can round, so this is approximately 5.2 square meters. So looking at number 2, we've done several hexagons today, so we are going to forego number 2 just for sake of time and look at number 4. So I already know here that my apothem is 4 square roots of 3. What I don't know is the perimeter of this shape. So remember, since this is a hexagon here, we do have a 30, 60, 90, where what that's pointing to is the longer leg, which tells me that my shorter leg should just be 4. Sorry, my backspace is not working right now. Let's try that again. So looking at this here, we've got 4 right here, which means we've got a 4 here, which means the length of one side is 8. So if I've got 6 of those, my perimeter is 48. So 1/2 of 4 square roots of 3 times 48 gives me approximately 166.3 units squared. So now let's look at a reminder of trigonometry. So we're going to find the area of this nonagon, And they've gone ahead and done a little bit of the work for us because they've done 360 divided by 9 and found that each of these central angles here would be 40 degrees. So when we drop the apothem, it's going to cut that into 20. Or sorry, yes, they're going to cut that into 20. And we're also going to take this side and cut it in half so that we've got 5 and 5. So they've kind of done a little bit of the pre-work here for us in terms of what information we need. So my apothem is not given yet, so I'm going to open up a parenthesis and leave that blank. But if this is a nonagon, I've got 9 sides of 10, so I've got 90 as my perimeter. So as soon as I know the apothem, I'll have my final answer. So like I said earlier, this is going to be a trig question, because this is not a 30, 60, 90 or a 45, 45, 90. So looking from 20, I currently have my opposite and my adjacent side. So thinking back to SOHCAHTOA, this is my opposite and adjacent, so that tells me I'm using the tangent ratio from 20 should equal the opposite over the adjacent. So remember, when your variable is in the denominator, we need to first get it out. So a times the tangent of 20 equals 5. Since a is being multiplied by something, we're going to divide by that something on both sides. Make sure, guys, before you type this in your calculator, verify that you are in degree mode. So 5 divided by the tangent of 20 gives you approximately 13.7. So bringing that back to our formula, half of 13.7 times 90 tells me that my area is approximately 616.5 square centimeters. So guys, like I said, we're not losing our ability to do trig, or 30, 60, 90, or 45, 45, 90 stuff. That is going to continue to come back to us. These are all the notes for today, so thank you so much for paying attention. Please email me if you have questions or concerns.